Hello SGD, Sacred Geometry Decoded. This will be a follow-on, so it's part two, but it's part two of a mini-series within a whole larger series. I'll put the links to those playlists in the description. Also, you'll find the previous part link in the description. So, the pyramid and metrology. So, the measurement, the geometry, and the information that is embedded in there. So, whether it's accidental or intentional, no smoking gun, we can't say, but if you long playlist, long series where I go through all the coincidences of metrology and how one blends into another and leads into another. If this was any other building, this was any other time, this would be just basically accepted, but there is a resistance to acknowledge these facts because they would really shatter a lot of the foundations of belief, which are built on assumptions, not on the metrology, not on the measurable, but the information embedded in the Great Pyramid. I'll also link a playlist which is how not just the Great Pyramid, how not just the major pyramids such as the other two on there at the Giza Plateau, Cowways, bleed together, but also have a link to the other lesser known pyramids, but also places such as Abydos and Thebes and really across Egypt. But the first part was looking at, well, the 360 degree compass, which is broken, so each degree is 60 minutes, and then each minute is divided into 60 seconds, just like the clock face, and touched on the origins of this. Now, this is hotly disputed, the exact time when it comes, but we do know it did exist in ancient Greek times, and for instance, some measurement systems, will be touching on that in this episode, revisiting and looking at the Salamis stone, for instance. Mark Wilson-Jones, he's done other fantastic work looking into ancient metrological reliefs, basically carvings and statues built in that buildings contain, which incorporate multiple sets of ancient measure, and how they come together at beautiful harmonic points. Now, first part I looked at the slope angle of a pyramid, so that's that 51.84 degrees give or take, or 51 degrees 51 minutes give or take, depending, and rightfully so, that's studied and there's beautiful information in there. So, but that's the slope angle, and again, lots of information. But what is I really haven't seen investigations of it, is the corner angle of the pyramids. So it's like a chicken or an egg thing. Is it the slope angle? Is it the corner angle? Well, they actually complement one another. And so so at the corner of the pyramid, you would have, and we'll do the exact one, but it's 42 degrees is the corner angle. Therefore, that is 48 degrees. Based on the 1 degree equals 60 minutes. 1 minute equals 60 seconds. We get these, so 42 degrees, and we'll get to 48 in the next episodes, but 42 in itself is an important number. Without a doubt, the Egyptians were dividing their year into 360 days plus 5. So they knew the 365-day year, but their calendar was based on 360 days plus 5, which was the intercalary period, which was basically when the gods were born, which would correlate to the solstice, how the sun appears to set in the same place for roughly 2.5 days. So therefore 2 solstices per year. That's where you get your 5 extra days for the 365-day year. But 42 degrees, 2,520 minutes, or what would that be? Sorry, 151,200 seconds of a compass. So now that's based on the corner angle, and therefore to see the corner angle, you have to be standing at the corner of a pyramid. Now this will be, I wouldn't call it a criticism, but I would just say what is lacking in regards to a lot of the investigations to a pyramid is to think of it as a 2D object, a triangle on a piece of paper, when in fact the pyramid is, by definition, a pyramid is a 3-dimensional object. It's not a triangle and a square, it is a pyramid. And if we examine the pyramid as a pyramid, well, there's a whole another level of information that comes out. These measurements will be based on the J.H. Cole and Petrie survey. Now, they go back to 1925 and earlier. However, modern surveys using more modern equipment have connected these. So even though these are people would say, well, it's old, but it's still correct. So these will be the basis for those measurements. Now, it just so happens that the maximum visible base, so when you look at a pyramid from ground level, the most you can see is 2 sides. That's one of the things in regards to 3D geometry. Think of it as a 3-dimensional object, not 2. And what we have is the maximum visible base length is somewhere between 1,100.945 feet to 1,511.962 feet. Very, very tiny little difference in margins. Now, what is the pyramid corner angle based on the idealized proportions where the base is 440 Egyptian royal cubits and the height is 280? We have a 7 high to 11 wide. Well, we do a bit of math on that, and what we find is that based on the idealized 7 to 11 proportions, the corner angle is not exactly 42 degrees, it's 41.985759 degrees. Well within acceptable margins of error, even by modern definition. But that would make 41.985759 degrees is 151,148.7324 seconds of the compass. And there we see the closeness between this set of digits and that. Again, I'm going to do a video on how the pyramid times 1 times 10 times 100 and times 1000 has so many connections in so many aspects. I'll come to that, so please bear with me for the moment, but times 10 times 100 times 1000 really is a thing, not just a couple of coincidences, but a whole series of coincidences that link the angles, the measurements, and well, so many other measurements of length and so many other aspects. But that's conveniently close, as we saw in part 1, but again, well within acceptable margins of error. Because the pyramid is not exactly equal length on each side, there are slight variations. The shorter side is 20 centimeters shorter than the longer side. So the southeast corner, these are the measurements. However, based on the survey by Cole and by Petrie, again confirmed by later surveys, there we see the northeast, southeast, southwest, northwest corner with an average of 1,511.577 or 1,511.565 feet. And well, now we can see those again, how close they're cut. Now, we're again, any other time for any other building, even modern times, if you can get it within those particular proportions over that particular margin of error, accuracy over a larger building, again, you'd be doing quite well. But of course, the difference between the sides of a pyramid is, proof is a big word, but it's very strong evidence that these deviations on each side were intentional, because just again, given the precision of the building and the simplicity of making each side perfectly the same, or within fractions, within millimeters, 20 centimeters, has to be an intentional error, because given the precision elsewhere that they couldn't get the base right within that level of accuracy, just really need a piece of rope or a measuring rod. You could do much better than that. So again, and there's information embedded in there, and that leads to another series of symphony of coincidences in regards to metrology, geometry, and geometry, earth geometry, earth measure. We'll get to that. But then the common thing will be English feet, meters, and ancient Egyptian royal cubits. What do they have to do with one another? We know that they didn't use meters, they didn't use feet. Well, let's look at that now. For instance, Salamis stone, which goes back to 5th century BC. The modern English foot is only a couple hundred years old. Not a couple hundred, a few hundred, maybe to time of Queen Elizabeth. However, the Salamis stone incorporates also the Samian foot, but we have the Doric, the Ionic, but we also have the common foot, which is the English foot. So the English foot was being used, for instance, in the Parthenon and other ancient structures, at least 2,500 years ago. We know that the Greeks were inspired by, they're not shy in telling us, they studied at Alexandria, they studied at Heliopolis, people such as Thales and Pythagoras, Plato and Eudoxus, all of these greats of the ancient Greek sciences, essentially trained in Egypt. So that the common foot, which is the English foot, much older than what people would believe. So that's like one thing, this legend, this mythology of the English foot being modern really needs to be examined, if not die. And so we see this English foot is an ancient unit. But also in regards to the meter, and I'll do more, I've done videos before, but for instance, Notre Dame Cathedral in Paris, Stefan van Leffringe showed this, how we see what he calls the medieval royal foot. He calls it the royal foot. I'm calling it the medieval royal foot just to differentiate it, but the medieval royal foot or the medieval royal yard is effectively 1 meter. The difference is 1/4 of a millimeter difference. Again, even to get that accuracy, well, you're doing very well. Now, that's not restricted to Notre Dame. We know that this unit was also being used in, for instance, Beauvais Cathedral. So 1 yard, medieval royal yard, is 1 meter. Now, why is that important? Because, for instance, Mersenne, who published the first information on the pendulum, 1 second pendulum, which was could call that the protometer. The Mersenne pendulum is 99.438 centimeters, or 0.994387 meters. That is a 1 second pendulum at 45 degrees north of the equator. Depending how far you are from the equator, the pendulum changes because there are slight variations in the gravity. Let's put that simple. However, 1 meter, a pendulum of 1 meter is 1 second. So there we see the 1 meter pendulum. And as Riccioli also discovered, you cannot swing a pendulum more than 30 degrees without affecting its timing. So just like a grandfather clock, you need to swing a pendulum at a shallow angle to get good timing. And 30 degrees, as pointed out by Riccioli in the 1600s, and also work by Mersenne. But what we find is that 30 degrees, 1 meter long, swung at 30 degrees, creates an arc of 1 Egyptian royal cubit. Now, Riccioli, who was doing this work on the pendulum, was essentially trying to measure time, 1 second, just like a metronome, to keep the choir in time. So there are musical connections to time. So you measure length with a pendulum, then you can measure time, then you can apply that to music as well. And so many other connections. I'll put the link to this particular video. I've done a bunch of these because it's just extraordinary symphony of coincidence, or a choir of chants just happens to all come together at these. And again, the published work on this is not, it's drawing a long bow, but it's not drawing it very long. But meters, seconds, cubits, also this would relate to the foot. So, but the generally accepted history on the origins of modern weights and measures, such as the English foot and the meter, is built on a lot of assumptions and myth. It's a half-finished story. We don't see those who often speak on it don't really have the whole picture, even though there's been a lot of great research and data on that, including, for instance, I mentioned Mark Wilson-Jones and his work on metrological reliefs. Also, if you apply that to ancient architecture across the world, you will just find that it simply is. Now it could be a coincidence, but it could be a coincidence that the sun rises in the east as well. So that could be coincidence too. One of the enduring myths in regards to measurement is that the foot is based on the king's foot, the 12-inch foot. This really is myth, because there is zero basis for it, yet it is considered a fact. But it's also not logical that such a thing would happen. Now, for instance, the ancient Egyptians, but also the cubit in general. Now, there are varying cubits depending on the culture and the time, but the cubit is known to be from the tip of your elbow to the tip of your longest finger. That's a cubit. Now, the foot is actually the forearm. And we can find evidence for that, for instance, in Vitruvian Man. But the foot is from your wrist to your elbow. So what's referred to as the foot also corresponds from the wrist to the elbow. The cubit is from the tip of the finger to the elbow. And this brings up the point. Now, when we measure, how do we measure? Well, I caught a fish this big. I show it with my hands. Maybe some clever gymnast would do it like this, but no one uses their feet or their legs to measure. We use our hands, we use our arms to measure, not our feet. The ancient Egyptians, for instance, the shoulder, as it's called, the cubit, the palm, or the fingers, these are all based on their hands and the arms. This is the way people measure. The uncia, which is where we get the inch from, is the thumb. The digit is the finger. So we divide 12 inches per foot, also, or 16 fingers per foot. The digit or the finger, even where the origin of digital or digits comes from. We measure with our hands. We do not measure with our feet and our legs. The only exception for this would be the pace, which is walking pace. So the distance, you walk one step, and the second step is a pace. Roughly translates to the height of a person. That is used to measure long distances, but the pace is not based on the length of the foot. It's not even really based on the length of the leg, because there used to be people were trained to walk at a certain length to measure long distances across the ground. Now, that was not based on their foot, it was not based on their leg, it was based on their pace, and you can train yourself to have a different pace. You can use a long pace, or you can take little baby steps. The pace does not correlate to the length of a foot or the length of a leg. We do not use feet or legs to measure. The same, but digits or digital, the same way we count with our fingers, digits, we don't count with our toes. It's like that, like that saying, he had to take off his shoes to count because he couldn't count more than what the fingers were. We don't measure like that. Now that brings us back to the feet, meters and cubits. This is an ancient practice. We measure with our feet and our hands, but also measurements of length. So I'll put these CPAK Alan Green trailer. He also looks in the connection between the allegedly modern English foot, the allegedly modern meter, and the cubit, and how they incorporate beautiful information and correspond to so many aspects. And I'll also put this, this basically gets it down there, but how also other ancient units of measure connect via the meter, the cubit, the second, at beautiful numbers, extraordinary sets of numbers. So there is a connection there. Now, admittedly, this is somewhat of a long bow to draw, and the evidence is circumstantial. However, this is measurable, testable. We can apply it to ancient sites, as where so much of archaeology is based on circumstantial evidence. So the traditional, to say the orthodox view, for instance, of Old Kingdom Egypt it's based on circumstantial evidence. The larger part of the view, we have a few little snippets of information, and then we have large gaps, and that's acceptable. So, but there is a resistance to measurable elements, for some reason, not quite acceptable. You'll also find, for instance, in Wikipedia, they'll call this general area pseudo-metrology. Now, I don't know what pseudo-metrology is. Either you measure it or you don't. That same narrative won't call it pseudo. Won't say that the traditional archaeology, the orthodox version, that's not called pseudo-archaeology, even though it's based on a few snippets of information with large gaps in between. There's a double standard happening here. They're both based on evidence, and the evidence, correlation is not causation, but well, it seems it goes one way or another. Then, of course, on the other hand, you just have really some wild speculation, which really isn't based on evidence, based on opinion. I'd call it religion in a lot of senses, but that applies to all sides of the spectrum. And I have to admit, we all have that in us ourselves. But what's measurable and what is not measurable? So one of my favourite quotes from Lord Kelvin: when you can measure what you're speaking about it and express it in numbers, you know something about it, in that sense that it's tangible. We can show this, and then if it's a one-off, well, it's a one-off, but if it's repeated, therefore it's a pattern and really should be accepted, but there is a resistance there. So that brings us back to that particular angle, the corner angle of a pyramid, which is not very well investigated or spoken of very often, but we see how it connects to seconds. And there we see the maximum visible base length. So again, the most you can see of a pyramid from ground level is 2 sides. And there we have the Cole survey based in feet with an average of 1,511.577 feet, and the Egyptian government survey, Petri, where his average is 1,511.5765. It's the same really, especially based on the average. But how does that connect? Well, I'll link this in the description. I did a small series looking at the long foot. So one long foot is 1.056 English feet. Now 1056 is 33 times 32. You can find that info in there. And how that applies to Stonehenge and to other sites, and also how that unit of measure applied to these archaeological sites, not only because everything's going to convert to something, okay, but what we have is that these conversions lead to beautiful numbers, very, very important numbers in the Doric, the Ionic, Samian, the Long Persian, Babylonian Royal, which would have applications to the Indus, ancient Indus civilization, also the Saxon foot, which is, it's the same. So Indus, Babylonian Royal, and the Saxon foot, which was used in England, North Europe, just before the allegedly modern English foot, at 288, 11, well, just the beautiful harmonic numbers. But so one ERC, one Egyptian Royal Cubit, is 1.7178438 English feet. And how does that apply? Well, the long scale, there we can see this long inches, 17173, 171781, etc. And again, coming soon, how the Great Pyramid, and well, Egypt in general, but especially the Great Pyramid times 10, times 100, times 1,000, incorporates beautiful mathematical proportions, but also the measurement systems, including the meter and the foot, and geodesy, earth-based measure systems as well. So there we see very, very close connection between the number of English feet per Egyptian Royal Cubit and how that would apply to long inches. Now again, just a declaration, how the long foot was divided up, was it divided up into 12 inches, or 3 feet equals the yard? No, can't say. This in itself is very, very speculative in that sense. So there is no smoking gun in that sense, but still the connections in there. And the dividing up into 12 inches is that base 12 system has a lot of connections, let's say, across the ancient world. But we do at least a curious oddity, but I would argue, based on the long scale and how it applies to other sites as well, it's again a beautiful coincidence. But that brings us back to, so at based on the 7 high to 11 base length proportions, 41.98 well degrees, and how well we see those very, very close connections in there. Ancient measure, so 5 Shesset, Hermes, Enoch, again, just the guides of ancient science were the guides of ancient weights and measure systems. And still, there is no science without measurement. We need these as also the basis of civilization. So, also link in the description, I'll put a pinned comment where I did a series, still ongoing. I need to come back and revisit it because there's a lot more still to add, and since I posted the last one, I found some other really nice things in regards to that. But how this, if you follow the causeway, it enters this doorway on what's called the Khafre Valley Temple, and from this particular point, the equinox, solstice, the seasons of Egypt blend so beautifully together. And also now on this particular image we see 14, so it looks like 14 degrees is bigger, but that's just based on the illustration I'm doing. But if you do a ground view, it is, as I showed in that series, you can test it, it is 14 degrees equally. But how these connect wonderfully together as well, And from this 0 point, we see the corner of the pyramid, not the slope angle. We see the corner, and that's where we get this 42 and 48 degrees, and how these will connect wonderfully to the seasons and some other information as well. That'll be in the next part. But assuming they had 360 degrees and then divided into 60 minutes and 60 seconds, again, well within, above 99.9%, well within acceptable margins of error, even by the modern scale. And then if you look at, again, other societies, other cultures across the world and their measure systems, one of the fundamentals of any civilization is a standardized weights and measure system, because one of the fundamentals of culture, of a civilization, is trade and economy. And if you don't have standards of weights and measure, it's just not going to happen. You can't operate. Pardon. And still now in science, we need standards of weights and measures so we can communicate with one another. And it just so happens that these ancient systems just come together in an extraordinary symphony of coincidence. And even so, ancient Egypt, Old Kingdom, we don't have smoking gun documents, but then we go up to the Greek and Roman period. Greeks and Romans inherited their knowledge from the Chaldeans or Babylonians and Egyptians. They tell us this blatantly as well. And so circumstantial, yes, but based on the fact that Egyptian measure systems still have a cubit and the palm and fingers and how they connect together, and then we apply it to not just one, not just two, but sites all across Egypt from the Old Kingdom right up to the later periods as well. So mythology regarding weights and measures, the modern foot and modern meter, well, no, not really. It's not a fact in regards to that, and there's a mountains of evidence to show that, again, for instance, the meter of a foot goes back long before the accepted narrative in regards to these things. Now, yeah, weights and measures, it's not the only aspect. I wouldn't say I lean towards it, but I would say that the weights and measure systems are so important in understanding it, because we can weigh and we can measure it, we can test it against not just across Egypt but across other parts. And then if we examine that through the surviving texts and through the surviving records, it really does come together. And at some point, coincidence stops being chance and starts being a plan, deliberate thing. And whether it's Thoth, Shesset, Hermes / Mercury, Enoch, what do they keep telling? They're the gods of weights and measure. If you can weigh something, if you can measure something, and you can embed information in there, and that's the beauty of this particular thing, is that the deeper you go, the more you go, it's almost never ending, and then it's at multiple levels as well. It all blends, especially in through the harmonic or the Pythagorean harmonies and Pythagorean tuning systems as well. So astronomy, music, geometry, and arithmetic just come together. And even when you incorporate slight deviations, for instance, on each side of a pyramid, if you round it off, it works really nice. If you include the variations and those deviations, it actually comes to, so 99.9%, include the variations, it's over 99.95% accurate. And so we really are talking millimeters on each side of a pyramid to get that perfection. But yeah, there's more to come on this, and again, this can be measured, tested, and it's repeated. So the next one would be the 48 degrees. Now, what I didn't mention is 42 is 2,520 minutes. Now, 252, for instance, is the outside corner angle of 252 degrees is the outside corner angle of a pentagon. 252,000 stadia was what Pliny described as the polar circumference of the Earth. So even that 252 is a beautiful number in that sense as well. But we'll go sticking with the pyramid for a moment. So that will be in the next ones. I hope you enjoyed. Have a good one.